If x and y are random variables, then the conditional variance will also be a random variable since its value depends on y, which is a random variable. So we can talk about the expected value and the variance of the conditional variance. So let's consider our PMF, and we want to construct a PMF with the conditional variance, then compute the expected value and the variance of the conditional variance. So note that our conditional variance can take on two values, the variance of x given that y is 1, and the variance of x given that y is 2. The probability of occurrence of these values will be the probabilities that y is 1 or 2. And so we find the probability y equals 1 and y equals 2. So as usual, the variance is the expected value of the square minus the square of the expected value. So we need to find the expected values of x and x squared given some value of y. So the expected value of x given that y is 1 is the sum of the products of the payoffs and the probabilities. And these are all conditional probabilities, so this will give us we also find the expected value of x squared, which is the sum of the squares times the probabilities, which will be, and so our variance is. Next, we'll find the expected value of x given that y is 2, which will be, and the expected value of x squared given that y is 2 will be, and so our variance will be, and so this gives us our PMF for the conditional variance, and so we can find the expected value and the variance of our conditional variance. So the expected value is the sum of the products of the payoffs and the probabilities. So the payoffs here are the variances themselves, and so we get the expected value of the square will be, and so the variance will be, now earlier we saw that the expected value of a conditional expectation was not a distinct quantity, it was just the expectation. But the variance of a conditional variance does appear to be distinct. It gives us some notion of how variable the variance is. However, that's only useful in some rather specialized contexts, so we don't typically worry about it. But notice that for our PMF, we found the expected value of x and the variance of x, and we also found the variance of the conditional expectation and the expected value of the conditional variance. And we notice that if we add those two together, we get which is the same as our variance, at least up to the round-off error. Was this coincidence? We'll take a look at that next.